Question 10. Return to the previous scenario. What is the p-value of this test? Okay. So in the previous question, we determined that choice D would give us the correct test statistic. Okay. So when you plug this into the calculator, you end up getting a z-score of negative 1.77. All right. So the p-value measures the probability of getting something as extreme or more extreme in the direction of the alternative hypothesis. Okay. Now, our alternative hypothesis is two-sided, so we're going to have to shade the area of both the left and the right tail. Okay, so negative 1.77 is in the left tail. We'll shade that, and then using symmetry, we'll find positive 1.77 and then shade the right tail. Okay. Now what I'm really going to do is on my calculator, I'll use normal CDF to find the left tail area, and then I'll just multiply that by 2, right? Because these two things are identical in size. Right, so we're going to do 2 times normal CDF, lower bound, negative 9999, upper bound, negative 1.77, mean 0, standard deviation 1. Okay, so that part by itself is it's about 0.0384. Okay, but then we've got to multiply that by 2. And so we get about 0.0767. All right, so this worries me a little bit because I don't see that in any of the answer choices. And I'm guessing the issue might be rounding. So I remember when we were doing the previous problem, I had rounded this. And this number, I believe, was rounded as well. And so all of that rounding we did earlier might have a carryover effect, and it might be the reason why we're getting an answer that doesn't match these. Now, if I had to choose, right, the closest answer choice to what we calculated would be D. Okay, so here let's put a question mark next to choice D. Okay, now here's another way that we can get the p-value, right? We can just use 2-prop z-test on our calculator. Okay, so stat. Okay, so it asks for x1, n1, x2, n2, and then the direction of the alternative hypothesis. So x1 is 28, n1 is 80, x2 is 50, n2 is 105, and our alternative hypothesis is not equal to. Okay, so when we run this on the calculator, we get a z-score of negative 1.72 and a p-value of 0.085. So yes, the answer will be